Satellites detect an anomaly near the American coast. Analysts traced the signal to a major naval construction site in the United States. Scans confirm the structure is far too large to be ordinary. Global surveillance systems lock onto one shipyard on the American coast. From orbit, the camera dives toward the eastern coast of the United States. Here, raw steel and fire become the body of a supercarrier. Module by module, the carrier is assembled with architectural precision. From inside the dock, the deck rises like an artificial horizon above the viewer. The island rises into view, revealing the unmistakable profile of a Ford-class carrier. From above, the scale of the Ford-class supercarrier is undeniable. The Anomaly is revealed as a monumental Ford-class supercarrier. The idea began when navies first imagined carrying aircraft to sea. At first, the flight deck was simple, fragile, and experimental. For a time, the carrier sailed beside the old giants of naval warfare. Before carriers changed the sea, they first changed the way admirals thought. Soon the carrier grew larger, more organized, and more deliberate in design. The deck became a system, not just a platform. By the time of global war, the carrier had become a decisive weapon of the sea. After the war, the carrier evolved again to meet the demands of a new age. Generation after generation, the carrier kept growing in scale, purpose, and complexity. And after a century of change, that evolution leads to the Ford class. Gradually, the carrier gained its own profile and identity as a warship. For a time, old battleships and new carriers sailed side by side, but the future had already shifted. By the time of global war, the carrier had matured into a decisive instrument of naval power. After the war, the carrier evolved again to meet the demands of the jet age. Over time, the carrier became not just a platform, but the center of an entire naval infrastructure. At this stage, the direct line to the modern American supercarrier becomes unmistakable. Step by step, that evolution leads to the Ford class, the next peak in a century of naval design. Aircraft carriers, floating cities, industrial machines, and complex military systems fused together. Inner decks and compartments must work in harmony behind the clean exterior. Steel bodies fuse flight decks, hangars, and living spaces through coordinated movement. Power flows through the carrier like blood through a vast engineered organism.
Are within spec, but I'll double-check the connection points.
Modern carriers must advance as internal complexity continues its relentless growth. A new carrier began as a new strategic requirement. The Navy needed a carrier built for longer, smarter service. The concept shaped the entire ship, inside and out. This carrier would rely on a different technological philosophy. Its concept also focused on decades of operating cost. Ford-class was the answer to a new era's demands. Paper concepts and digital models refine the carrier's hull from the start. Strict discipline divides internal space, flight decks, and compact, capable islands. Early planning integrated crew living, medical spaces, and essential internal service routes. Technical volumes, weight, and stability must work together through every design choice. The digital model aligns perfectly, forming the Ford-class before the first steel. Industrial shipyards and dry docks provide the physical foundation for supercarrier scale. Production halls and giant cranes turn immense steel into manageable ship assembly. Enduring industrial bases enable shipyards to assemble giant modules into massive ships. American heavy industry and infrastructure turn decades of expertise into physical reality. Industry and suppliers turn naval programs into physical reality at the shipyard. Heavy industry formed the hidden foundation of the carrier. Strategic schedules and work sequences set the rhythm before the first steel. Coordinated workshops and organized shipyard space ensure modules join exactly as scheduled. Strict internal logistics and planned movement routes ensure each stage prepares the next. Strict order, sequence, and control define the assembly before major work begins. The arrival of steel on rail platforms provides the ship's physical foundation. Heavy trucks and deliberate unloading expand the essential flow of incoming steel plates. Large components arrive in strict industrial order before the first major assembly begins. Careful sorting and identification ensure materials enter the shipyard's internal flow. Delivery logistics and organized steel movement establish the build rhythm before assembly. Fabrication halls turn steel into ship material through precise shaping and cutting. Bending and precise geometry turn flat steel into essential ship structural forms. Cleaned edges and precise marking ensure each part maintains its exact sequence. Careful preparation of plates and load-bearing beams defines their specific structural roles. Primary parts from careful metalworking now move into the next assembly stage. Large-scale shipbuilding began with repeatable metalworking steps. The future ship first emerged here as processed steel parts. The ship first became visible as parts joined into sections. Frames began defining the future shape of the hull. Bulkheads divided the ship's interior before the outer form was finished. The section already looked like part of a future ship. The section became the bridge between parts and modules. Scale emerged through repeated section assembly. Sections became the first large physical fragments of the ship. Sections had grown into large three-dimensional modules. The first rooms appeared inside the growing module. Part of the interior outfitting was done before final assembly. Even the superstructure was built as large modular blocks. Repeated module construction accelerated the growth of the ship. The carrier's architecture was already visible in the modules. Deep inside the ship, workers prepared the compartment for reactor installation. Its foundation had to be aligned with extreme precision before any heavy equipment arrived. A major reactor module was lowered into the hull through an open construction access. Inside the compartment, the heavy unit was guided slowly toward its seating position. Once lowered, the reactor component had to be seated with exact precision. After placement, workers secured the unit and verified its final alignment. Around the reactor, crews began installing the supporting technical systems. Protected connections and major service lines were routed into the reactor zone. After the heavy installation, specialists inspected every mounting point and surrounding system. Deep inside the carrier, one of its most important power sources was being installed. Heavy engineering systems were now entering the ship itself. Large machinery had to be placed with exact precision. Installed machinery became part of the ship's inner structure. Technical lines began linking separate machines into one system. Installation order mattered as space became more limited. Here, great mass had to meet exact precision. The ship was receiving its hidden engineering core. The shaft line depended on exact alignment across a long distance. The force path began with carefully prepared stern supports. Precise alignment would determine the reliability of future movement. Installation order mattered as stern spaces became more constrained. Reliability came from repeated accurate work across the stern systems. The first power lines were pulled through the bulkheads. Heavy power cables were fed into the new tray runs.
Clear on this side.
The first major power unit was lowered onto its foundation.
Okay, it's dropping into place. Solid.
Once in place, the power unit had to be secured and aligned.
Take it down slow.
Power cables were brought to the installed equipment. Power routes were built across multiple compartments.
Steady pull, Supervisor.
The ship's empty interior was filling with real power infrastructure.
Looks good, lock it down.
Power installations spread through the ship on many levels at once.
Watch the cables overhead.
Major power units were connected into the ship's wider network. After installation, the power system had to be checked in detail.
to panel 4.
Workers were building the carrier's internal power network.
Check on A12.
The dry dock was being prepared for the first major carrier modules.
Copy. Moving slowly left.
Huge cranes were ready to lower the first heavy module into the dock. The first giant module was lifted and moved out over the dry dock. The module was lowered onto the prepared supports at the base of the dock.
Slowly.
Confirm seated. Hold position.
A second module was brought in to meet the first section of the hull.
Coming down easy. Gap is closing.
Watch the starboard side. Clear the rigging.
The gap between the two giant sections was reduced inch by inch. Workers had to match not just the seam, but the ship's internal structure as well.
Ready for welding prep.
Before welding, the aligned sections were temporarily secured in place.
Here.
Then permanent welding began along the outer seam of the hull. Then another giant block was brought in to extend the growing hull. The process repeated again and again as the hull began to take on a single form. Separate sections were turning into one continuous steel body. Every new joint had to be reinforced and checked as the hull grew. What began as separate modules was now clearly becoming a single ship. In the dry dock, separate giant modules were being turned into one unified hull. Cables and piping, installed side by side, build layered internal engineering environments.
Diagram either.
The corridors were beginning to resemble the arteries of the ship itself. Service zones were filled with access points, branch lines, and maintenance infrastructure.
Done tightening the bolts on this level.
The voice you selected does not support this language. Please click the upper right corner to switch to another voice. Internal routes shaped for systems movement, maintenance, and essential shipboard logistics.
Node 7.
7. Copy that. Making the connection now.
In some areas, the ship already felt fully alive with engineered complexity.
Cables up to the 3rd tray. Let's keep this area clear.
Inside the steel giant, the carrier's future working life begins taking shape. Inside the carrier, living spaces for thousands of future crew take shape. In berthing compartments, rows of bunks define compact sleeping spaces for crew. Showers and wash spaces were built as essential parts of long life at sea. Domestic corridors tied the living and service spaces into one everyday internal route. The dining spaces were being prepared for one of the ship's most important daily routines. The galley was assembled as an industrial kitchen built to feed a vast crew at sea. Recreation spaces gave the crew a place to recover between watches and work. Medical spaces made the carrier more than a ship. They made it a self-contained world at sea. On the Gerald R. Ford class, the flight deck was not just a surface, but a complete operational system. Deck tractors formed part of the constant logistics that kept the flight deck working. Its scale reflected the ship's real dimensions, about 337 meters long, with the flight deck roughly 78 meters wide.
Lines for platform 3 before the next pour.
Already on it, we should have the readings by noon.
Inside the hangar, storage, servicing, and movement followed a carefully organized logic.
Having trouble with the starboard side alignment.
The catapult infrastructure was built into the deck as one of the defining systems of the Ford class. Across the deck, every route and work zone was arranged with operational purpose. Scale and organization define this 100,000-ton nuclear supercarrier. The flight deck becomes a controlled working environment, not just an upper surface. Even without aircraft in motion, the deck showed that this ship was built to handle a large air wing. Realistic Ford-class island under construction and dry dock, showing angular geometry and scaffolding. Realistic mast structures on the island focus on assembly, cables, and frames. Realistic radar array mounting on Ford-class island shows planar panels and framing. Realistic deckside external systems show housings, service cabinets, and utility structures near island. Integrated Ford-class island view combines radar faces, masts, and sensor architectures. Final paintwork brought the massive outer hull into a unified visual finish. Across the flight deck, final surface work prepared the carrier for its finished operational layout. Along the ship's outer sides, final detailing brought structure and finish into alignment. The island was being refined into the clean, controlled form that defined the ship's silhouette. Even at the bow, final exterior work refines the carrier's completed silhouette. Along the ship's outer sides, final detailing aligns structure and finish. Fresh paint and refined surfaces gave the carrier a unified and disciplined exterior presence. Before launch, the carrier's final exterior work had already defined the ship the world would soon see. Realistic technical operations space shows ship systems being aligned into unified logic. Realistic interior circulation scene shows passageways, ladders, and internal route validation. Realistic engineering compatibility scene shows technicians checking system interfaces and PowerPoints. Engineers review Ford-class technical readiness, order, labeling, and operational access. Integrated Ford-class function check, monitoring, communication, and support systems validation. Technicians perform final Ford-class system checks, electronic status panels, and documentation. Unified Ford-class systems, electrical, communication, and monitoring as one organism. The first lights activate, transforming cold steel into living ship. Power was no longer waiting in cables. It was moving through the ship. Separate systems were beginning to act as one environment. The carrier transforms from built metal into a functioning organism. For the first time, people fill the carrier's spaces.
PT gear now.
As living areas were occupied, the ship began to take on a human rhythm. Empty structures become purposeful routes for movement and life.
The manifest against the pallet count.
Before routine could begin, the ship's spaces had to be prepared for real life aboard. Simple tasks began, marking the ship's first daily functions. Even the shared spaces were beginning to reflect the presence of a living crew.
Water checks are complete and logged in the system.
Support services provide the carrier with continuity of life.
After that, all systems report green.
Gradually, the rhythm of the crew began to match the rhythm of the ship itself.
Afternoon. The galley is open soon too.
By then, Life had begun to move through the carrier just as surely as power and air. Immense hull gains buoyancy as the dry dock fills completely.
Is a delicate operation as the massive vessel prepares for buoyancy.
The carrier begins its first monumental, controlled movement within the dock. The newly afloat carrier rests in the basin, transitioning from structure to vessel. The carrier moors at the pier for final completion work.
Easy now. Bring her down slow. Watch that starboard clearance.
Crews perform final exterior fitting out on the moored Ford-class carrier. Personnel move between pier and carrier as shipboard life begins. Technical systems hum as crews perform diagnostics at the pier.
Hold synchronization and verify checklist item 7B.
The carrier sits nearly complete, its finished hull reflecting at the pier. The carrier sits moored, a near-complete vessel undergoing final fitting out.
Clear to proceed with the pump test.
The carrier begins mooring trials, transitioning from completion to systematic verification. Technicians validate power distribution in the carrier's engineering compartment. Auxiliary systems and ventilation undergo controlled verification in machinery spaces.
Confirms auxiliary power is online.
Technicians verify shipboard communications and signal hardware during mooring trials. Staff coordinate parallel system checks in the shipboard control room. Personnel validate internal routing and logistics along carrier passageways. Completed mooring trials confirm the carrier's readiness for sea trials. The carrier advances through the harbor channel toward open water. Engineering systems and power monitoring operate steadily during sea trials.
Parameters for the current load.
Crew monitor ship systems and navigation during underway coordination checks. The carrier executes a precise turn during open sea maneuverability trials. Internal systems and crew movement function steadily during open sea trials.
For the next rotation.
Integrated shipboard systems undergo comprehensive monitoring during active sea trials. The carrier demonstrates full maritime capability during final sea trials. At last, the ship stood revealed not as a project, but as a carrier in full. By this point, the carrier no longer returned as a project, but as a completed ship.
Yes, sir. All certifications are logged in the system.
Before transfer, readiness still had to be confirmed, not only technically, but formally. This was the moment when responsibility for the ship began to pass from the builders to the Navy.
States Navy gratefully accepts delivery.
The quiet handover marks the transition between two distinct lives.
We need that starboard crane operational now. Roger that. Moving the pallet to elevator 3. Watch the deck edge foul line.
The crew moves to their stations to begin final operations.
Readings are stable, Chief. We're proceeding with the checklist.
What had once been coordination was now habit, and what had been habit was now life aboard.
The port visit.
The carrier interior reflects a world of structure and routine.
Reading stable parameters here. Logs are updated.
Service represents the long continuation of the ship's established identity.
Confirm the voltage regulation on panel 4.
Now the carrier stood not as an achievement alone, but as a lasting presence. From dockside steel to strength at sea, the carrier is complete. The carrier maintains a steady course through open blue waters. The carrier stands ready, a complete symbol of engineering and strength.